Hi guys, welcome back to my channel. How are you guys? Okay, I'm fine. Let's learn a small concept of Avogadro's number today, and we are going to link that Avogadro's number to figure out number of atoms or number of molecules. Which is just represented by n. In some books, they're using n small a or big A. I'm not using this one, otherwise you're getting confused with sodium. So this is just a number. It has some value which is equals to 6.02 into 10 to the power of 23. So how can we relate this with elements or compounds? Let's check. How can we relate this with elements and with compounds? Elements, mostly metals, and compounds. Elements which are in the monoatomic state, and compounds, you know that it has more than two same or different atoms. Let's see. I will give you one example to explain what is the actual meaning of Avogadro's number. Look at that. 1 mole of sodium weighs 23 gram. Okay, that's fine. And how many atoms it should contain? So how to figure out? Look, I will show you one thing. This is the chemistry textbook. So if you weigh, so roughly it's 50 grams. But how many pages that book contain? It's 280 pages. In the same way, each mole has two faces. One, its weight, and how many actual atoms or molecules are present in the element. So 1 mole of sodium weighs 23 grams, and 1 mole of sodium contains Avogadro's number of atoms, which is 6.02 into 10 to the power of 23 atoms. So we can relate 23 grams of sodium contains that many atoms. So 23 gram of sodium of Na contains 6.02 into 10 to the power of 23 atoms. Okay. It is like kind of confusion. To avoid the confusion, I'm going to write one simple formula to work out the number of molecules or atoms. Yeah. Can I rub the board? Okay. Look at that. So compounds have molecules and elements have atoms. Let's see some example. So find the number of moles present in 9 gram of water molecule of H2O. You can easily figure out number of molecules. And this question, I want to just twist this question. Find the number of molecules. This time, look, molecules present in 9 gram of H2O. How to figure out, suppose this is A, this is B, how to work out. So the first one is easy. The first one, which formula we have to use to work out the mole? For A equals to mole mass over its MR. What's the mass given? 9 gram. Okay. And AR of water molecule, MR of water molecule is 80. I showed you how to work out the MR of each compound in my previous video. Just follow my previous videos, which is nothing but 1 over 2, 0.5 moles. How can we work out the number of molecules present in 9 gram? Step 1. So we are doing B. Step 1, figure out the mole. For question number B, just now we have done the moles. Moles equals to 0.5 gram. Now how to work out the molecules? So number of molecules or molecules is nothing but mole time Avogadro's number, which is nothing but 0.5 times 6. That's that Avogadro number, 6.02 into 10 to the power of 23. Or I'm writing. Is that okay? Can I write here, guys? So molecule molecules equals to 5 into 6.02 into 10 to the power of 22. I've taken divided by 10, so I've taken 1, 10 cancel from that. So 30.02 into 10 to the power of 22, or 3.02 into 10 to the power of 23. It's just a calculation. So you can use the calculator. Mostly, I'm not using the calculator because I have a habit to do like this kind of maths. Now, can we do one more question? Okay. Find the number of atoms present in 4.4 gram of propane molecule. Okay, how to figure out this question? Let's see. This time we have to work out number of atoms present. Propane, what's the chemical formula of the propane? Propane C3H8, which is a hydrocarbon. It is a saturated hydrocarbon. I will teach you the chemical formula of propane in my future videos, focusing the formula of the propane, but we have to work out the number of atoms present in the propane. Okay, step 1. Work out its mole. First, work out the mole, which is nothing but mass. What's the chemical form? What's the formula to work out the mole? Mass over MR. Mass is given 4.4 gram, and MR C3H8 carbon 12 times 3, which is 36, hydrogen 1 times 8, which is 8, so total 44. Now mole or moles 4.4 divided by 44, which is equals to 0.1. And just now we have seen how to work out the molecule from the moles. So number of molecules equals to moles times is Avogadro's number, which is nothing but a bigger number. So molecules equals to how many mole we got it? 0.1. 0.1 times 6.0. Sorry guys, just I want to. Can I rub this? Yeah, 6.0 into 10 to the power 6.02 into 10 to the power of 23 molecules. Okay, so 6.02 into 10 to the power of 22 molecules. Now, how can we work out number of atoms after we got number of molecules? So look at how many atoms are there in propane. Just work out the number of atoms in propane. C3, so carbon has 3 carbon atom, and H8, 8 hydrogen atom. 3 plus 8, total number of atoms in propane are 11. So step 1, step 2, and the last step 3, number of atoms. How can we work out the number of atoms? See, step 3, molecules time total number of atoms present in propane, which is nothing but 11. So 6.02 into 10 to the power of 22 times 11. So use your calculator. You can use your calculator. Use your calculator now. So 6.602 into 10 to the power of 22 atoms. Can you work out the number of atoms, number of molecules for a given compound or element? So this way we can work out number of molecules or number of atoms present in the given compound or element. Now, sometime they will give you number of molecules or number of ions or number of atoms, and you have to work out number of moles, which is nothing but slightly twisted form of asking the question. Now, number of moles equals to total number of particles or entities divided by Avogadro's number. What are particles? Particles are nothing but molecules, atoms, or ions. Particles is nothing but number of atoms, or number of molecules, or number of ions. All three are same. Now I will give you one question. Let's figure out that question. Find the number of moles present in 6.02 into 10 to the power of 20, 21 molecules of sodium carbonate. Use this formula. Number of moles equals to total number of particles. What are the particles given here? That's the particle given divided by Avogadro's number. So moles equals to 6.02 into 10 to the power of 21 divided by Avogadro's number. What's the Avogadro's number? N. 6.02 into 10 to the power of 23. Guys, I want to write all this thing here. So, which is nothing but, if you take that one, all the positive sign become negative. So this get cancelled. So 1 into 10 to the power of 21 into 10 to the power of minus 23. 21, 23. So 1 divided by 100, which is nothing but not 1 moles. Can I give you one more example? Yes? Okay. One more example. Let's do one more example. See, now you're getting confident how to work out number of atoms, molecules for a given element, or if they will give you number of particles, how to work out its mole. I want to give you one more example. Find the number of molecules, find the number of moles present in 3.011 into 10 to the power of 23 atoms of aluminium. So how can we work out number of moles present in aluminium having that many atoms? Okay, use the formula. Number of moles equals to number of the particles divided by Avogadro's number. Number of the particles are nothing but atoms or the molecule or the ions. So number of particles is given to you 3.011 into 10 to the power of 23 divided by Avogadro's number, which is 6.02 into 10 to the power of 23. This roughly half 1.2, which is 0.5 moles. So please do revision on these questions, and I have seen this type of question in many past papers. In my next video, I'm going to start molar volume. So we can learn how to work out the molar volume in my next video. And in my next video, I want to relate molar volume, moles, and Avogadro's number. So guys, I want to stop my lesson here. Please come back in my next video and we will learn a new topic and some more formulas which is useful to work out your amount of substances. Okay guys, thank you so much for watching my video.